complicate completely. This is extremely funny. Can you solve this? If you're one of those who are attracted with this title, then you are in for it. If you think of any alternate method of solving this question without following the methods that will be shown in this video, kindly drop your method and your comment in the comment section, and I will be so glad to engage with you. A viewer of one of our videos simply say, when did simplify become complicate? Of course, simplification can become complicated in order for you to get the solution to every given question. And that's exactly what you're going to see as the solution to this video unfold. Now, this question is going to test your knowledge on their ability to use the laws of indices. Now, the question says simplify completely 2 divided by 3 to the power of 2 divided by 3. Now, how do we go about doing this? As you watch this video, don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Now, before we start, I want us to apply the first law of indices we're going to apply. Do you recall this law in indices that if you have a to the power of x divided by y, this can be equal to the denominator becomes the root, that's the white root of a, and the numerator becomes the power. Do you recall this? Now, this is exactly the rule, one of those rules we are going to apply. So if we apply that rule, that expression is now going to give me the cube root, right, of 2 divided by 3, and all of these will be to the square root of all squared, right? And this is going to give us what? Now let's look at this. In the next step, we're going to simplify. Now recall another law of indices. Remember, I told you we're going to be applying the rules of indices. If you have x divided by y all to the power of n, this can simply be equal to x to the power of n divided by y to the power of n. We can separate the index. So if we have that expression given to us, that means we can simply separate that index, and that is going to give us a full cube root of 2 to the power of 2, right, divided by 3 to the power of 3. Let's take it slow. Now, if we simplify that, we're going to have this expression to now give us the full cube root of 4 divided by 9. Great. Now we've gotten to a point whereby we need to apply more laws of indices. Now, recall another good law of indices that says if you have the total cube root of n, x divided by y, this can simply give us the cube root of the nth root of x divided by the nth root of y, right? We can separate the roots. Now, if we have that and we apply that, we are going to have that our solution to become the general cube root of 4 divided by 9 can now be equal to the cube root of 4 divided by the cube root of 9. Great. Now, at this point, what do we do? Now, if you are watching this, pause this video a little and ask yourself, what do you do from here? What is this going to give you? Now, I want you to recall some logic we are going to apply in solving this question. Now, if I want to solve this question, I want to analyze something. If I have an expression 1 divided by the nth root of a, This can simply be equal to 1 divided by the nth root of A multiplied by, I can have the nth root of A to the power of n minus 1, right? Divided by the nth root of A to the power of n minus 1. Now, you know that all this whole expression, if I simplify all this whole expression, I can simply have this. Because definitely this will cancel out this will cancel out this, and then this will still give me this. So I've not changed anything. Now I can still apply that logic in expanding this expression. Now let's see how it goes. That expression can now give me a separate root. We can now have that expression to now give me the cube root of 4, right? Divided by the cube root of 9, multiplying the cube root of 9 to the power of 3 minus 1, right? Divided by the cube root of 9 to the power of 3 minus 1. Now, did I change anything? I did not change anything. Now, if you look at that, it will still give you that same solution. But we can still expand. If we expand this whole expression will now give us the cube root of 4 divided by the cube root of 9, right? And this would be multiplying the cube root of 9 to the power of what? Of 2 divided by the cube root of 9 to the power of 2. Great. Now, if I simplify that, if I go ahead to simplify that, I'm going to have some given expression. Now, if I simplify that, I'll have to look at using some rules of multiplication. If you look at this is 9 to the power of 1, right? If you look at this is 9 to the power of 1. So if I multiply those two expressions, I'm going to have this to become the cube root of 4 multiplying the cube root of 9 squared, all divided by, if the denominator multiplies, we're going to have the cube root of 9 to the power of 1 multiplying the cube root of 9 to the power of 2. Now look at the denominator very well, and you can see that we can simply simplify the denominator. Now if we simplify the denominator, we are going to have that expression to now give us 3 cube root of 4 multiplying the cube root of 9 square, and this will be divided by the cube root of 9 to the power of 3. Now, without much looking at this, we find out that the cube root will cancel out the cube, right? And that expression will now be equal to the numerator will now give us the cube root of 4 multiplying the cube root of 9 square is going to give us 81, right? Divided by 9. Great. Now, in the next step, we are going to simplify further. And if I simplify further, recall that 81 can be broken down to give us a perfect cube, right? If we have 81, 81 can be equal to 27 is a perfect cube, 27 multiplied by 3, right, will give us 21. So we can have that expression to be equal to the cube root of 4 multiplying the cube root of 27 multiplying 3, and all of these will be divided by 9. Now in the next expression, we can still simplify this to become the cube root of 4 multiplying the cube root of 27 multiplying the cube root of 3, right? And all of these will be divided by 9. Great. Now, if we simplify that all through that, we are going to simplify that, and you find out that this is simply going to give us 27 to the power of 3, or the cube root of 27 is going to give us 3, right? So we are going to have that expression to give us the cube root of 4 multiplying, that will give us 3, multiplying 3 cube root of 3, and all of these will be divided by 9. Now, what do we see? We can simply simplify this further. 9 here can give me 3, and 3 here can give me 1. 3 here can give me what? 3. So you see, I've reduced that expression. So if I reduce that expression, I'm now going to have the cube root of 4 multiplying the cube root of 3, and all of these will be divided by 3, right? So let's simplify this. If we simplify this, looking at that thoroughly, we have cube root, one common cube root multiplying one common cube root. Now remember something in the laws of indices. In the law of indices, if I have, let's make this out. If I have the nth root of n of x multiplying the nth root of y, because they have one common nth root, this can be equal to, we can combine the nth roots and have this as x multiplied by y, right? So we can use that expression here. If we use that expression here, then we are going to combine the cube root and have this as 4 multiplying 3, and all of these will be divided by 3, and that will be a simplified solution to that question. Now, if we simplify that, we are simply going to have that expression to now become the cube root of 12 divided by 3, right? And that is that. Now we can simplify that to still be equal to 12 to the power of 1 divided by 3, all divided by 3. Now this is simplifiable and is simplified to the lowest time. So this becomes the solution to that question given to us up there. I hope this is not complicated. If you have a simpler way of solving this question without losing all these principles of logarithms we apply, kindly drop your comments in the comment section. I will be so glad to engage with you. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and see you next time.